In this video, we'll take a look about linearization. So when approximating values using local linearity or linearization, you'll have an equation that looks like this. So you have m tangent, which is just your slope, right? We should all be familiar with slope. And then you have x minus x1 plus y1. So these values right here are basically your coordinate values um, or your order pair, right? Well, this will be your actual value that you will use. Now that I explained a bit about this equation, this still seems a bit abstract to me, so let's take a look at some examples. Okay, so in this example, right, the first thing we want to do is we find the tangent line using a close approximation to this value, right? Because we're given f of x, right, a cube root of x at x equals 8 to approximate the cube root of 8 over 1, or cube root of 8.1, excuse me. So the first thing we want to do is find the tangent line. So to find the tangent line, we're going to have to find the derivative of f of x. So to find the derivative, we're going to do this. And then we'll do chain rule. So what we have the inside, or to find the derivative of this function, we'll have to rewrite this as an exponent. So we know that cube root of x can also be x to the power of 1 over 3. And now we can use power rule. So we bring it down, we bring the exponent down, and we keep the x, but we subtract 1 from the exponent. So giving us with negative 2 over 3. And then we bring down negative exponents to the denominator, so we have 1 over 3 cube root, cube root of x squared. So now that we'll have that, we're going to plug in an approximated value, which is going to be this value, because we can attempt to plug in 8.1, but we won't know what it actually is. So when we plug in x into this value, so let's see, f into 8 is going to be 1 over 3 cube root of 8 squared, we know that's 64, right? And we know that the cube root of 64 is going to be 4. So we have 3 times 4, which is going to be 1 over 12, right? So then this is our slope, right? This is because we know that the derivative gives us our slope. And this point specifically will give us our slope at that specific point. So now we can plug in this value here. So if we plug in here, let's x is equal to 1 over 12 minus x. And we're missing these values, right? So to find these values, we're going to have to plug them in to the original function. If we take a look at the original one that we had, our original function, we have f of x is equal to cube root of x. So what happens when we plug in 8 into here, right? So we have f of x, or f of 8 equals cube root of 8, which we know is just 2, right? So we know that our output is 2, so therefore our value is 2, and our input was 8, so this is 8, right? So this is good now that we have our equation. So now that we have our equation, we can plug in our actual value that's inside here into this equation. And this will give us our approximated value. So if we do that, right, so we do ln of 8.1 equals 1 over 12 parentheses 8.1 minus 8 plus 2. We know that 8.1 minus 8 is just going to be 0.8. Oh, my bad. 0.1. 0.1 plus 2. And we're going to bring everything down. 1 over 12. And then let me scroll a bit down. So then we know that we can write this decimal into a fraction. So we can still carry this process out much more cleaner, right? So in this way we have equals 1, right? We multiply the numerators and we multiply the denominators, which 12 times 10 is just 120, right? And we have plus 2, right? But we can't just add fractions that don't have the same denominator. So what we're gonna have to do is we're gonna have to find we're gonna have to make this into the same denominator as this, which we know that we can have the same denominator if we just multiply this denominator by 2 and put this over, and right, so 120 times 2 is 240 over 120. And we know that when you divide this out, or if you were to plug this into a calculator, you'd get back to 2. This is equal to 241 over 120. And this is our approximated value of cube root of 8.1. So now that we have our value, right, we can actually find the error, right? So the error, to find error, because when you're approximating, anytime you approximate, you're approximating. So it's never exactly the same. And therefore, we can find how much we're off by using this formula. So we have absolute value of the actual value minus the estimated value, will use an absolute sign. This will give us our error, right? This is going to be equal to our error. For an example like this, you will have to use a calculator, which kind of does defeat the whole purpose of approximating, but here we go. So the formula is right, and then we'll plug in the actual value. So we have cube root. We have cube root of 8.1, which is going to be 2.0083 minus the estimated value, which what do we get when we divide 241 by 120? And we get 2.00833. Right, and then what do we get when we subtract these? We should get a value of around 0.000034. And that is our error. So in this example, we learned how to approximate and how to find the error. Let's take a look at another example. Okay, in this example, we're already given our function values. So this will make the process a lot much easier. So first, we can write down the equation. Right, so we have ln of x is equal to m of tangent of x minus x1. Let me write that a bit better. Of x1 plus y1, right? So if we take the look at here, right, we look at our function values, we're given the derivative and the non-derivative. So here, this gives us our slope, right? Our slope at this specific point, right, at 3, right? This gives us our function values. So with this one, we can plug them into the x1 and y1. So if we were to do that here, right? So let's plug in the values equals 5, right? Because we've already saw this is our slope at 3, and then x minus, and then we use these values of 3 at 3, right? They give us our coordinate plane. So we know that what we're plugging in, or our x is 3, and then our output is negative 2, right? Let me negative 2, right? And we're told to approximate at f of 3.1. So we simply just have to plug in 3.1 into L of x. So L of x, when we plug in 3.1 into 5 times 3.1 minus 3 minus 2. So we use what's inside, basic PEMDAS is going to be 0.1 minus 2. And then we multiply this out, which is going to be 0.5 minus 2, which if you don't know the decimal, right, you can always rewrite these as a fraction. So we have 1/2 minus 4 over 2, which is just negative 3 over 2 is our approximation or estimate of f of 3.1. And that is our answer. With this example, I kind of want to leave you guys to do it. So here, you're given the implicit curve of x squared plus ln of x over y is equal to 1. So calculate the error approximation of x is equal to 1.25 with the error formula, or the error approximation formula of absolute value of f of x minus the approximated of L of x is going to give you your error, right? So the first thing you'll do, right, is you're already given your y output, right? So if you have your formula, right, so you have your formula for your approximation is equal m tangent of x minus x of 1 plus y of y1, right? So you have your y value already. So you can already set this as 1, right? Because that's your output when you plug, if you were to plug this in, right? So then all you need to do is just find the derivative function of this, and then after you find this, you'll be able to plug this value, right, where you find here, as your slope. And then you'll plug in 2.25 in here, and then you'll be given your approximation value for this equation right here. And then find your error. And once you have your answer, comment down below. If you have any questions regarding this problem, let me know in the comments. Also, this problem is a bit complicated. You will need a calculator, just so you know. And yeah, thank you for watching.